In this video, we are going to explore one improper integral. So we're going to decide from the graph whether or not the integral 0 to infinity of 2x e to the negative x dx might converge. If the integral might converge, find out whether or not it does, and if so, the limit to which it converges to the nearest thousandth. Now, my guess would be that if you're taking this on a final, if you're taking this to wrap up a class, it's going to converge because your teacher wants to know, can you do the math? Can you integrate it? So your first step is to graph. So we want to graph it, and here's our graph here. And as we look at our graph, we are looking from 0 to infinity. And it looks like it certainly might converge because we would be looking at this area here. And what you'll see is this is getting closer and closer and closer and closer to 0. So much so that I can't keep drawing it in there. So this definitely looks like it might converge. And so the first thing that I'm going to write is this might converge. Now, this is an improper integral because in the integrand it says 0 to infinity. Other ways that you might see an improper integral is if there's an asymptote or if there's a discontinuity in the area in which it's wanting you to look. But this one is very obviously improper because it's 0 to infinity. And so what we want to do here is we want to rewrite this as a limit problem. We want to get rid of this infinity bound. And so let's just call it b. And by taking that infinity out, we're going to say, okay, well, let's watch the limit as b approaches infinity. So we're going to take the limit as b approaches infinity, and we've replaced infinity with a b in the integral of 2x e to the negative x dx. And this problem is especially fun because it's also going to test you on whether or not you know how to do integration by parts. I know this is an integration by parts because I have what clearly would be a u, and I have what I would call my dv. So I have a product here. So I'm going to make my little box, and in my little box, I'm going to put my u, my du, my dv, and my v. So my u is going to be 2x, which would make my du 2 dx. My dv is going to be e to the negative x dx, meaning that my v would have had to be negative e to the negative x. Because when I took the derivative of this, the negative would drop down, making that positive again. So now I'm ready to integrate. I'm going to multiply this way. 2x times negative e to the negative x is going to be, so I'm going to bring down this limit notation. And so that's going to equal negative 2x e to the negative x. And then I'll go this direction. And 2 dx times negative e to the negative x would be negative 2 e to the negative x dx. And we are still integrating from 0 to b here. And of course, we're going to evaluate it from 0 to b. So this notation gets a little bit ugly, but that's okay. Now it's a matter of simplifying and dealing with this last part of the integral. Again, I'm going to pull down this notation here. And this is going to become negative 2x e to the negative x. A negative and a negative makes a plus. But then I'm actually going to do the integral, which then makes it a negative 2e to the negative x. And we're going to integrate from 0 to b. I'm going to simplify this a little bit further just to make my life easier. And I'm going to say we're looking as the limit as b approaches infinity. I'm going to factor out a negative 2 and an e to the x, which is going to leave me with x plus 1. And now I'm ready to plug in my bounds. So I'm going to plug in my upper bound first. So I'm going to have the limit as b approaches infinity of -2 over e to the b times b plus 1. And then I'm going to subtract my lower bound, which is going to be -2 over e to the 0 times 0 plus 1, which is 1. And this whole thing is going to turn into -2 over 1 times 1, but a negative and a negative makes a positive. So this whole thing turns into +2. And now I can plug in this infinity. So now I can plug in this infinity. So I'm going to have -2 times infinity plus 1 over e to the infinity plus 2. You have to evaluate which infinity is going to be bigger. Is the infinity on the top going to be bigger, or is the infinity on the bottom going to be bigger? And really, the infinity on the bottom is going to be bigger because e to the infinity is significantly larger than a linear infinity. And so because the e to the infinity in the denominator is bigger, this whole thing goes to 0. And so we have 0 plus 2. And so this converges to 2. It converges to 2. Okay, let's do a quick recap here. You read the problem, you graph it. You figure out that it might converge. You replace that improper integral with some letter, and you make it a limit problem. You evaluate the integral just like you always would, and then you plug in your upper and lower bounds. And then at the end, you evaluate a limit just like you normally would. If it equals any number, it converges. If it equals infinity or negative infinity, it diverges.